الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will continue talking about counting. Let's begin with the types of selections or drawings. Let omega be a sample space. The selection from omega could be done in three different ways. It could be done successively with replacement, successively without replacement, and simultaneously. Let's see this example. An urn U contains 7 red balls and 5 blue balls. This is the urn. It contains red and blue balls. 3 balls are randomly selected from U. We need to choose 3 balls from this urn. The question is to give different examples about each of the given selections. Well, if the selection is done successively, give me an example about the 3 balls that are selected successively. These 3 balls could be selected blue, blue, blue. Well, the first could be red, the second could be red, the third could be blue. The first could be blue, the second could be red, the third could be red. The first could be red, I put it aside, then I choose a blue ball, I put it aside. The first could be red, I replace it back to the urn. I choose another ball which is blue, I put it back to the urn, and then I choose a third ball which is also blue. I can choose a blue ball from the urn, I replace it back to the urn, I choose another ball which is red, I replace it back, I choose a third one which is blue. All of these selections are called successive selections. Now here we have successive with replacement and successive without replacement. With replacement means we choose the ball, then we put it back to the urn, and without replacement means we choose the ball and we put it aside. And what is the difference between these two terms? We're going to see it later. Now notice here, if I choose blue 1, blue 5, blue 2 is not the same as blue 2, blue 5, blue 1. So the first selection is not the same as the second selection. That's why here we say that the order is important. We're going also to see the meaning of order later. Well, what happens if I want to choose the 3 balls simultaneously? Simultaneously means at the same time. So within one selection, I choose the 3 balls at the same time. These balls could be 3 blue balls. They could be 2 red and 1 blue, 1 red and 2 blue, or 3 red. Well, let's take specifically 3 blue balls. These balls could be blue 1, blue 2, blue 3, could be blue 3, blue 4, blue 1, could be blue 1, blue 5, blue 3. But here the order is not important. So if I choose blue 1, blue 2, blue 3, it's the same as blue 3, blue 2, blue 1. Let's begin with the first type of drawing, which is the successive drawing without replacement. Omega is a sample space. In a successive drawing without replacement, we select one item, we put it aside, then we select the second item, we put it aside, we select the third item, we put it aside, and so on. That's why it's called without replacement. So, in successive drawing without replacement, an item cannot be selected more than once, and the order is important. Let's see this activity. An urn U contains 7 red balls and 5 blue balls. 3 balls are selected randomly and successively without replacement from U. So we need to choose from here 3 balls successively without replacement. In other words, we choose one ball, we put it aside, we choose another one, we put it aside, and then we choose a third ball. The question is, how many different balls are there in the urn now? How many balls are in the urn? In fact, we have 12 balls. If you select one ball successively without replacement from you, how many different balls would still be in the urn? So in case we choose one ball from the urn and we put it aside, we're going to have 11 balls. And if you select another ball successively without replacement from U. How many different balls would be in the urn? In fact, we're going to have 10 balls, and if we select a third ball, we're going to have 9 balls. So whenever we select a ball, we look at its color and then we put it aside. What do you notice concerning the number of different balls? In this case, the number of balls was 12, then it became 11, 10, and 9. So we can see that the number of balls in the case of a successive drawing without replacement decreases by 1 each time we select one ball. So the total number of balls will be decreasing. Let's continue with activity 1B. An urn U contains 2 red balls, 2 black balls, and 1 green ball. 2 balls are selected randomly and successively without replacement from U. In how many different ways can these balls be selected? So in fact we have 5 balls, 2 red, 2 black, 1 green, and we need to choose 2 balls out of these 5 balls. How do we need to choose them? We're going to select them successively without replacement. Let's see how do we find these ways. The first ball could be R1, and if the first ball is R1, the second ball could be R2, B1, B2, or green. In this case, the first selection is R1, R2, then R1, B1, R1, B2, R1, G. Well, the first ball could be red 2, and if the first ball is red 2, the second ball could be red 1, or black 1, or black 2, or green. And the selections would be R2, R1, R2, B1, R2, B2, and R2, G. And the first ball could be a black one, and in this case we're going to have 4 different ways which are given here. And the first ball could be black 2, and this is the second ball. And finally the first ball could be green, so the second could be R1, R2, B1, or B2, and these would be the different selections. So in this case, the question is, in how many different ways can these balls be selected? You see, we have 20 different ways, and we don't have any repetition here. You see, each way is different from the second way. So we're going to have 20 different ways. Now notice here that 20 is 5 times 4. In fact, as you see, we have 5 groups, and each group contains 4 different ways. So the answer is 5 times 4. Now, how can we find a relation between 5 times 4 and the given of the question? Let's see the results from activities 1A and 1B. In a successive drawing without replacement of P items out of N items, so if we have N items and we need to select P items out of them successively without replacement, the total number of items, which is N, decreases by 1 each time we select one item. This is the first result, which is very important. And the number of possible different selections would be N multiplied by N minus 1 multiplied by N minus 2, blah blah blah, P times, and this is what we call the arrangement NP. Let's see this example. An NV contains 10 balls. 4 balls are to be selected randomly and successively without replacement from V. In how many different ways can these balls be selected? So what's important in this question, we have 10 balls and we need to select 4 balls out of these 10. How do we need to select them? We select them successively without replacement. So according to this result here, we're going to see that the number of ways would be 10, which is the total number of balls, multiplied by 9, multiplied by 8, multiplied by 7, and this would be 40 different ways. Or we can use the arrangement, which is here. A, from 10 items, we need to choose 4 items, and this would be also 40 using the calculator. Let's take an application. In grade 12, we have 15 girls and 12 boys, so the total is 27 students. 3 students are to be selected randomly and successively without replacement from grade 12, and the question is to find the number of different ways of choosing these students. Try to do it alone. So in this case, we have a successive drawing without replacement. We have 27 students, then it decreases by 1 to become 26, then 25. Because we need to choose 3 students, so we multiply 3 numbers by one another to get this answer. Or we can use the arrangement, which is in this case A. From 27, we need to choose 3, and we get the same answer. Let's continue.